This is problem number 1 from section 9.1. In this problem they say, if possible, solve the nonlinear system of equations. Now we know they're nonlinear because we obviously, in this equation here, have an x squared term, meaning that they're nonlinear. It's a nonlinear system. So what we want to do here is, anytime we have to solve a system of equations, we want to identify the appropriate approach. So there are 4 ways to solve any system of equations, and the first way is graphing, the second way is substitution, third way is elimination, fourth way is matrices. Now anytime you have a nonlinear system, usually I'm going to be looking for either solving it using graphing or solving it using substitution. Now most of the time I'm going to use the graphing part just to kind of get a grasp of what the graph looks like and where the solutions lie, but most of the time I'm going to use substitution to actually solve the equation algebraically. So let's use substitution in this case. First thing we'll do is identify terms that are in both equations. So we've got a y term that's in both equations. So I'm going to solve the linear equation for y and then plug it into the quadratic equation up above. So we're going to subtract 2x over. That's y equals negative 2x. And then I'm going to take negative 2x, substitute it in. So this is the substitution part. And I'm going to say y equals negative 2x. So I'm going to plug that into this equation. So I get x squared. This will be minus 2x now, equals 15. Now I have a quadratic that I can solve, and we know whenever we want to solve a quadratic we need to set it equal to 0. So I'm going to subtract 15 over. So subtract 15 on each side. You get x squared minus 2x minus 15 equals 0. Now when we go to solve a quadratic, you got to remember we have 4 ways to solve the quadratic. We can factor it, we can complete the square, we can use the quadratic equation, we can use the square root method. For me though, I usually try to factor it, especially if it's got a leading coefficient that is something, or that is 1. So I'm going to try and factor this, and if I can't factor it, I'm going to go straight to the quadratic equation. So let's see about this factoring. I know the factors of 15 are negative 15. I'll just write this up here, negative 15. Factors are negative 5 and 3, or 5 and negative 3. Which of these two add up to negative 2? Well, negative 5 and 3 add up to negative 2. So I'm going to factor this down to negative 5, 3, so it's x minus 5, and then x plus 3 equals 0. So I can use the zero product property here that says x minus 5 equals 0, or x plus 3 equals 0. And I can find out that one of my x values could be 5, or the other x value when I subtract 3 over could be negative 3. Now this is different than what you've gotten with linear systems of equations, because the linear systems of equations, they give you a singular x value. Because we have a nonlinear system of equations, we're getting 2 x values, meaning there are 2 possible input values that will give solutions. So because I have 2 different x values, I need to write the coordinates 5 comma something here, and then the other one will be negative 3 comma something. And the reason I kind of left some space here is I got to figure out the y value for each of these to actually get my 2 solutions. So how do I figure out the y value when I plug in input of 5? Well, I just go back to this equation right here, y equals negative 2x. So that would be y equals negative 2 times 5, which is negative 10. So 5 negative 10 is one of the solutions. And then I do the same thing over here. I say y equals negative 2 times negative 3, and I get 6. So negative 3, 6 is another solution. So 5 negative 10 is one solution, negative 3, 6 is the other solution, and these are the 2 possible solutions for this problem here.